Good evening. I'm Nancy Bell, and I am the Vice President of the Environmental Forum of Marin, and thank you so much, everyone, for joining us this evening. This is very exciting to have this full a room. Happy to say at least half of you I have never seen before. That's even better. Just out of curiosity, how many people here are forum graduates? So yeah, just about half the room, maybe a little bit more. Thank you. And also thank you to everyone whose efforts went out to invite people to join us this evening. This is a really important topic and very timely, as Obama had mentioned climate change very prominently in his inaugural address recently, and we hope to hear a lot about it in his upcoming State of the Union address. So again, very timely. We have a few notables. I just want to point out Kate Sears from our Marin County Board of Supervisors is here with us. And I want to thank Damon. Where are you, Damon? Damon Connolly from the San Rafael City Council. Damon is sponsoring us tonight, so thank you very much. We appreciate that. And we have quite a few of our board members from the forum here tonight, if you just want to raise your hands. And out in the hallway, there's a couple more, including Vicki Rupp, our president. How many here have never heard of the forum before? Okay, well, we know that they're out there. So you're going to learn a lot tonight, I hope. And I hope you can hear me okay. And pardon my voice. I sound worse than I feel. I'm no longer contagious, but no hugs. So what I'd like to do, first of all, is a little bit of housekeeping. Cell phones, if you would please turn your cell phones off. And bathrooms are out in the hallway, down the hall. Ladies' room is the first left. Men's room is the second left. And tonight is the opening session of our lecture series 2013. We are doing this a little bit differently this year. The lecture series consists of 6 sessions that will cover 3 topics: climate change, food, and waste. And each topic will have 2 sessions. And as you're experiencing tonight, the first session will be a Wednesday evening from 7 to 9 here in the City Council chambers. It will basically be the big picture, the overview of that topic. Whereas the Saturday session, which will be 10 days later for 3 hours, 9 to noon, will be more of a practicum, getting into the specifics of the situation of the topic in regards to Marin. So on February 9th, we will be doing climate change, Marin's response, at which time we will talk more specifically about how Marin is preparing to address the impacts and the causes of climate change and what our specific threats are, particularly in regards to sea level rise and fire. So I hope you can all plan to come on the 9th and hear more about that and participate in a very important discussion. We will have sign-up sheets when you leave tonight if you want to sign up for any of the future series, or you can always go to our website, which is listed up top here for more information. As we get speakers lined up, we'll update our website with information. And also about a week prior to each session, you will get a special email that will announce the speakers for the upcoming session, so you can make your plans accordingly and hopefully be able to join us. Also, we do have some materials out. I'm just going through all my pieces of paper here. We have some materials that you can take home with you also, including these bookmarks, which are very handy. It's just a replicate of what you see on the screen of the days and the times of the upcoming series. So please grab one of those also on your way out. I just want to take a minute and give you an overview of what we're going to be talking about tonight. Now I have to see. I already mentioned the timeliness of this in regards to Obama's comments about climate change. And I think this is really key to what we're going to be hearing about tonight. This topic is huge. There's no way we can cover all of it tonight. and often is the case, you might leave here with more questions than answers. Take in what you can. We've made an effort to bring a climate scientist in tonight to talk about the science behind climate change, connecting the dots of why this is so important and why the urgency, along with realizing we've got to talk about the solutions, because this is a pretty heavy topic. So we've brought in an energy analyst from the Union of Concerned Scientists. I'll tell you a little bit more about both our speakers in a second. But to address some of the good news, and particularly what's happening here in California, towards leading us towards a clean energy landscape. There's a lot going on that we may not be aware of on a day-to-day basis, so it's good to hear that there's a lot of action going on behind the scenes. We are going to ask you to hold your questions until the end of each speaker's segment. We're recording tonight, not live, but for future broadcast on Marin TV, Channel 26. And on that note, I want to thank Marin TV, who are our media sponsor. So this session, along with our other evening sessions, will be broadcast at a future date on Channel 26. You can also go to their website, cmcm.tv, to get updates about other broadcasts that they have. So that's also going to be available. And we'll also send an email out, of course, to let everybody know when these will be broadcast. I'm not used to standing behind a podium. I'm feeling a little bit confined here. So moving forward, I just want to tell you a little bit about each of our speakers. I'm going to tell you about both of them first, and then we'll have them speak rather than my interrupting with introductions in between. I first want to tell you about Dr. Phil Duffy. Dr. Duffy is with the Lawrence Livermore National Laboratory. And I know for me, and a lot of people I've spoken to, when I think of Lawrence Livermore Labs, I think about weapons and defense stuff, not climate change. But the reality is that Lawrence Livermore has had a long history of involvement with climate change research going before 1990. So that tells you something. They're a government agency, and they've been keeping their eye on this. Phil there are detailed bios for our speakers on the website, so I just want to give you some highlights. Phil is a senior scientist at Lawrence Livermore Labs. He's been working there since 1986. 2011 to 12, he was a senior policy analyst at the White House Office of Science and Technology Policy, where he handled issues related to climate change. So Phil has been right on the front lines of this in Washington. Also from 2008 to 2011, he was the chief scientist at Climate Central, a nonprofit dedicated to increasing public understanding and awareness of climate change. Our other speaker tonight is Laura Wisland from the Union of Concerned Scientists. The Union of Concerned Scientists is one of many esteemed independent organizations that continues to play a key role in keeping our planet's most pressing problems in the forefront and on the minds of our decision makers. They have played a critical role in helping our state legislature understand the seriousness of climate change. So USC has played a big role in this. UCS, sorry. Now, Laura is a senior analyst, energy analyst at USC. She is, why do I keep saying that backwards? UCS, sorry. Developing state policies that will effectively increase the amount of renewable energy in California. And as we know, it's difficult to talk about climate change without talking about energy and fossil fuels. You just can't separate the two. And clean energy is what we look forward to help us in reducing our greenhouse gas emissions. So Laura will be able to address for us some of the initiatives that are going on in the state of California towards meeting specified goals between now and 2050. Yeah, so let me also top that off. 350.org has just opened a Bay Area chapter, and Frances Aubrey, who is the founder of that chapter, will be here this evening to talk to us later on what we can do as individuals and what's going on with 350. So thank you for bringing that up, and we will be definitely talking about that. Are we good, Phil? Okay. I'm going to now Phil Duffy.
Okay, well, thanks all of you for coming. I always enjoy a chance to talk about a subject that I'm so interested in. It's really more of a, well, I hate to use the word passion, but it is more of a passion than a vocation. You know, to add to what Nancy said, you know, I've been working on climate change since about 1990, and actually I got involved in it. My personal journey in climate change actually started, as all of our journeys start, with my mother. And my mom, like me, was trained in physics and was a climate change researcher in academia, actually, and I got interested in climate change in the 1980s, and at that time, to me, it was an interesting science problem. And I did not, although there were people at the time, including Al Gore, for example, who had the vision at that time to recognize that this was an impending societal problem. I did not. I just thought it was an interesting science problem. Of course, over the years and decades, all of our awareness of the societal ramifications of climate change increased, and as that happened, my career has actually diverged more and more from science towards, well, as Nancy said, towards communicating with the public about climate change and, of course, policy formulation in the White House. So I have a lot I want to try to cover tonight, but it's really just sort of the basic things that I think scientifically literate folks should know about climate change, starting with how do we know what's happening, and then how do we know, well, we believe that humans are, at this time, the main cause of climate change. How can we possibly know that? And I'll explain some of the science behind that. I'll mention a few societal impacts, and as far as societal impacts go, what I'm really going to focus, well, I don't have much time to talk about it, but what I'm going to focus on is the societal impacts, some societal impacts that are happening here and now, because I think one of the misconceptions about climate change is, oh yeah, this is something, it might cause a problem at some point down the road, maybe someone will drown in Bangladesh, okay? But it's much more than that. It's actually manifest right here, right now, but in fact, a lot of the manifestations are not recognized for what they are. So I'll mention a few things here. An area of increasing both scientific and societal interest is the relationship between climate change and extreme weather and climate events, which we've had in abundance for the last couple of years. I'll mention some of what we know about that. And then I am going to say, although Laura's mainly going to talk about solutions, I am going to just mention a couple of things that the Obama administration has done on climate change. And by way of sticking up for my former boss, you know, I actually think that although certainly the record of this administration on climate change is imperfect, I actually think that they've done more than they commonly are given credit for. And I just want to mention two examples of things that we worked on that I think are useful and I feel proud of. Okay, so this is a joke slide, but the truth is this is actually a pretty technical talk. Nancy said to hold the question, so we'll adhere to that. But I hope it doesn't go by too quickly, and I hope it's not too obscure. Okay, so how do we know climate is changing? And this is the most widely cited piece of evidence, although maybe not the most important. And this is what we call in the business the surface thermometer record. It's basically measures weather station measurements of temperature. This represents tens of thousands of weather stations, measurements going back to 1880. These have been these little things here are volcanic eruptions, by the way. And this is showing the history of globally average surface temperature over the 20th century. You can see this period of rapid warming early in the 20th century, a period of stagnation, and in fact a little bit of cooling towards the middle of the 20th century. And I should say, we think that this is primarily of natural origin. And then after around 1970 or 1980, you can see this rapid warming, which we believe is primarily not of natural origin, primarily caused by humans. Now, you may also notice, if you look closely, I updated this, so this includes the 2012 temperature, which is this last dot right there. Anyway, you may notice that over the last 10 years or so, it actually hasn't gone up that much. It's actually been relatively flat over the last 10 years or so. And then this is something that the climate change denier community has made much of. But I want to point out that if we look closely at the last 50 years of the temperature record, you can see that there are, if you cherry pick the periods, you can find short periods when there have been periods of either no warming or actual cooling. None of these has any statistical significance. And the fact that there's 1, 2, 3, 4, 5 cooling periods in this 50-year period, nonetheless, doesn't mean that there's not an overall warming trend. So the fact that it actually has been relatively stagnant for the last 10 years is not unprecedented, it's not unexpected, and it certainly doesn't disprove that the underlying theory of climate change. And what's going on in all of these periods is natural variability. Okay, so what this temperature record represents is a combination of an underlying warming trend due to increasing greenhouse gases and then natural variability, which can go up or down. And it's just like in a stock market, you know, you may be in a bull market, but that doesn't mean the stock prices go up every single day. There's going to be down days and even down weeks. And we're seeing something similar in the thermometer record. Okay, so that's weather stations on the ground level. Over the last decade or so, a lot of effort has been put into trying to measure temperature trends from satellites. It turns out it's actually very difficult to do, and the main reason it's very difficult to do is that we're trying to look at trends which are basically temperature trends basically about 1/10 of a degree per decade, which is a very tiny trend. And unfortunately, you know, you can measure that from satellites, but the lifetime of any satellite is much shorter, is only a few years, and so you're piecing together records from different satellites. It turns out to be a lot more difficult to do than anybody realized at first. And the first couple of times that the satellite record was analyzed for long-term temperature trends, they weren't there. They seemed not to be there. And this, again, was something that the denier community made much of. Subsequent analyses of the satellite record have, in fact, shown that the early analyses were flawed. And at this point, and what this is showing is that the surface measurements, which I just showed you, and the satellite measurements agree very well. And it's actually interesting from a science point of view that, in fact, they're not measuring exactly the same thing, because the satellites are measuring, well, the thermometers measure temperature right at ground level. The satellites are measuring temperature somewhat above ground level. And in certain parts of the world, in fact, you expect significant differences. But the bottom line message is, at this point, satellites corroborate the surface thermometer record. This is an interesting viewpoint. This is simply a map of temperature change between a reference period 1951 to 1990 in the last 4 years. And the reason I'm showing you this is that one of the denier myths about climate change is that it's due to urbanization, increasing heat islands. Well, all you have to do is look at where's the warming occurring. It ain't where, you know, it ain't where the cities are. Okay, so that's simply that can't possibly be right. Now, we're now moving down into the what Melville called the watery part of the world. You know, ocean warming is very important, and ocean warming is very important because it takes a hell of a lot more energy to increase the temperature of the ocean than it does the atmosphere. And so evidence of ocean warming really does document that the planet is out of balance in the sense that it's absorbing more energy from space than it's emitting. Unfortunately, ocean observations are very sparse, and particularly observations of the subsurface ocean are very sparse. So it's actually difficult to establish temperature trends in the ocean, but there are a few estimates. These are 3 of them. They all show substantial warming over basically the same period where the atmosphere is showing rapid warming. And this amount of warming does represent a substantial, as I said, energy imbalance between the incoming energy from the sun and the outgoing energy. So this is a very important, despite its limitations, a very important piece of evidence documenting the warming planet. Precipitation is also influenced by climate change, and unfortunately, precipitation is also one of these things it's very spotty, so it's difficult to observe. There are some regions of the world where it's relatively well observed. The United States is one of them, and this is actually showing it's a trend, but it's not a trend in the mean precipitation or average precipitation. It's the trend in the fraction of precipitation that comes on the 10% of rainiest days. So what is that telling you? It's telling you that there's a tendency for more extreme precipitation, which is one of the expected consequences of a warmer atmosphere. And that's been documented in, it's difficult to document, but in places where the observations are good and where we have long records, that tends to be what we see. This is Arctic sea ice. The black curve is an observed trend in Arctic sea ice extent. I think that's the September extent. Now, this does not include 2012. 2012 had the lowest ever measured extent of Arctic sea ice. So that if 2012 were on here, this would be down even farther. The blue and the red curves are results from climate models. And one thing that's interesting about this is, and the blue curves is an older generation of models. The red curve is a newer generation of models. Neither one is capturing the rapidity with which Arctic sea ice is disappearing, although I think the newer models do a little bit better. And in the same neighborhood, now sea ice is important because it affects ecosystems. It also has a large influence on the climate, in fact, by reflecting radiation back into space. But loss of sea ice actually doesn't affect sea level. A lot of people don't realize that. And the reason is simply that the ice is already floating. And so whether it's floating in a liquid form or floating in a solid form, actually it doesn't matter as far as sea level is concerned. But what does matter as far as sea level is concerned is Greenland, okay? And we now have a very good 10-year record, 11-year record from satellites of changes in the mass of the Greenland ice sheet. And that's what I'm showing you here. There's a seasonal cycle, but you see this overall sharp decreasing trend. And furthermore, not only a decreasing trend, but if you look closely, it appears to be an accelerating trend. So Greenland is melting, and it's melting faster and faster. This is showing measurements on Greenland actually from seismometers, which are measuring not earthquakes, but large-scale motions of the ice. Actually, I first showed this plot in 2005, which is here. And at that point, the trend looked extremely ominous. And what this is showing is large-scale motions of the ice, suggesting that things are breaking up, which is not what you want. Since then, it's actually slowed down a little bit. So who knows what that means? But there's certainly things going on in the Greenland ice sheet. This is a representation of other land ice sheets, glaciers, which are smaller land ice sheets, typically in mountains. And this is showing over the last 50 years. Each curve is supposed to represent the sum total glacier mass in a different continent. And what this is representing is the fact that nearly all glaciers in the world are shrinking. And actually the units of this, if you can read it, is millimeters of sea level. Okay, so this means that glaciers on this continent have shrunk enough to add 6 millimeters to the global sea level, which isn't a hell of a lot, but there you are. Okay, so this is sort of a quick tour of a lot of different observations, but I think together they paint a very compelling picture of it's getting warmer. I mean, there's simply no way to avoid the conclusion. We have different lines of evidence, all pointing to that conclusion, and each one is pretty robust, and I think together there's really no doubt that it's getting warmer. So, I wanted to show you, before I leave this, I do want to show a few local or regional things. This is California. These dots represent temperature trends in California. The red dots are warming trends. The sole blue dot is a cooling trend. And this, I should say, these are, on the left, this is daytime temperatures. These are nighttime temperatures. And one of the things we get really interested in is the fact that the nighttime temperatures are warming up faster than the daytime temperatures. But what do you see? Basically warming essentially everywhere in California. And one of the ramifications of this is less snowpack. And this is a similar sort of diagram. This is here now, the red dots meaning decreases. These are places where snowpack has been measured, April 1st snowpack. The red dots are places where the snowpack has been measured to be decreasing, the blue dots where it's increasing. The southern Sierra actually is not losing snow because the elevations are higher there. And so although it is getting warmer, it's not really below freezing. I'm sorry, it's not getting warming enough so that it's above freezing. So the warming isn't having much impact there. It's having more impact in the lower elevation northern Sierras. But the bigger picture in much of the West is a loss of snow. And one of the implications of that I mentioned is water scarcity. And the way this manifests is a tendency for more river flow earlier in the year and less river flow later in the year. And we care about that because our water supply relies on late season river flow to keep the reservoirs full after the precipitation has stopped. So runoff that occurs April, May, June, July is very important in maintaining our water supply. And what these two plots are showing is two different versions of the same thing. And what it is, it's the fraction of annual river flow occurring basically after April 1st. And what we see is that's decreasing, and it's decreasing because the snow is melting earlier, and it's decreasing, in fact, because more of the precipitation is actually, I'm getting hot, I want to take my coat off. And because more of the precipitation is coming in the form of rain to begin with, and that of course runs off right away. And this sort of thing, I should say, has been documented in other parts of the West. These are just from California. So this is an indicator of shifts in the hydrology that are really have implications for water supply reliability. Okay, so some evidence for warming. How can we possibly distinguish between warming that's due to natural causes and warming that's caused by humans? And in fact, we can, and I can prove it to you in one slide. Okay, and oh no, first a joke. Okay, this is two guys in a bar. I don't know anything about global warming, but these ice cubes are melting like crazy. Okay, so that's not how we do it. This is how we do it. Okay, this is conclusive proof of global warming, and this is showing the temperature record and the price of a postage stamp. Okay. All right. So I fooled you. Two jokes in a row. You weren't expecting two jokes in a row, right? Okay. So how do we really do it? Again, there's multiple lines of evidence, and starting with some basic things that we understand. And we understand that we're adding greenhouse gases to the atmosphere, and this plot shows atmospheric concentrations of 3 greenhouse gases. The most important by far is carbon dioxide. That's the red curve. This goes back 2,000 years. It shows pretty flat, and then all of a sudden in the last 100 years or so, a rapid increase. We know why that is. It's from fossil fuel burning primarily. It's somewhat also deforestation, but primarily fossil fuel burning. There's absolutely no mystery about either the fact that this increase is occurring or why it's occurring. There's absolutely no doubt about that. So we know that we're adding greenhouse gases to the atmosphere, and we've understood the theory of the greenhouse effect, which I'll review in a second. We've understood it for a couple of 100 years, okay? And it's also important to mention that, in fact, the Earth has a natural greenhouse effect. And there are greenhouse gases, carbon dioxide, methane, all those gases exist naturally in the atmosphere of the Earth. That's been understood for some time. It's been understood that those gases cause the Earth, I mean, they're the main reason. The fact that we have greenhouse gases in our atmosphere is the reason why the Earth is more hospitable than the Moon, which is subject to extreme temperatures. So my point is that the greenhouse effect is not an untested theory, as some of the climate change deniers will have you believe. It's a natural phenomenon. It's been understood for several hundred years, and so the idea that we're adding to it and making it actually just a little bit worse should not be difficult to believe. Now, if you look on a long time scale, it's clear that carbon dioxide is a very important driver of climate change, and this is showing the red curves is temperature estimates, and the blue curves is measurements actually from ice cores of carbon dioxide concentrations. They have these actually going back now 800,000 years. I'm showing you between 300,000 and 400,000 years. And what do you see? You see these two quantities, carbon dioxide and temperature, vary in lockstep. And it's a very, very strong relationship. And again, one of the denier points that they jump on is, well, what's driving what here? Is temperature driving carbon dioxide, or is carbon dioxide driving temperature? And the answer is both, okay? We know carbon dioxide drives temperature. If you add carbon dioxide, I'll explain, but I think you all know if you add carbon dioxide to the atmosphere, it blocks outgoing energy. But it's also true that if you warm the planet over a long period of time, that tends to cause carbon dioxide to come out of the ocean. And so temperature drives carbon dioxide drives temperature. From the point of view of climate change policy and influence, it really doesn't matter. The point is they go up together. So if you add carbon dioxide to the atmosphere, temperature is going to go up. And it's happened in the past, and surely it will happen again. Okay, so the greenhouse effect starts with the sun. The sun shines, and most of the solar radiation actually is deposited on the surface. Some of that is reflected by clouds. Some of it's reflected by the ground. Roughly 30% on average is reflected. About 70% is absorbed. What happens to the stuff that's absorbed? It goes back out into space. But the key thing about the greenhouse effect is that it goes back out into space as longer wavelength infrared radiation, okay, because the Earth is cooler than the sun. That's the fundamental reason. And what happens with this outgoing radiation is greenhouse gases, and here's a carbon dioxide molecule right there, okay. Greenhouse gases can block and do block some of that outgoing radiation and reflect it back down towards the surface of the Earth, and that's actually what causes the warming. And so the key point is that the greenhouse gases don't block the incoming solar radiation, which is shorter wavelengths. They do block the outgoing infrared, which is longer wavelengths, and so they have this warming effect. And again, this has been understood for a couple hundred years. So from going from theory to models, it turns out that the only way we can explain the warming of the last 50 years or so is with greenhouse gases. And I'm going to show you a couple plots that look quite similar. The red curve here is the temperature history, which you've seen a million times already. The gray, which is sort of a thick line because it's representing a lot of different climate models smushed together. So what this is showing is simulations that include natural factors, estimates of solar variability, and volcanic eruptions, which have an influence on climate. But it does not include human factors like greenhouse gases. And what this shows is you can't these simulations don't, which are shown in the gray here, they don't have this rapid warming of the last 50 years. Okay. Also, if we do model simulations where we only have the human effects but not the natural, then we can explain the warming of the last 50 years but not the warming that I pointed out in the early part of the 20th century. It really takes both human and natural influences. If we put both of those into models, we actually get something, the gray curve here, that actually does quite a good job of representing the temperature history of the 20th century. So, so one of the things about this is, well, this is actually, before I comment, I'll just show you, this is a similar sort of thing now for the ocean, okay? And I mentioned that it's really important, ocean warming is really important because it takes a lot of work to warm up the ocean. And what are you seeing here? This is the top of the ocean. This is 700 meters down, so not very far down, actually. And this is the observed temperature change, okay, the red thingy. So what is that saying? It's saying, well, there's been warming at the top of the ocean and less and less and less and less and less as you go down, which is exactly what you expect. If you're adding heat at the top, it takes a while to percolate down, okay? And these, again, are families of model simulations. These are families of model simulations with increasing greenhouse gases. It shows about the right behavior in terms of warming. These are families of model simulations without greenhouse gases. It doesn't show that kind of behavior. Now, the comment I was going to make is, let's see what this is. I'll make the comment now. The comment I was going to make is one of the alternative explanations for the warming of the last 50 years, the denier explanations, is solar variability. Okay. Well, as I said, I wrote an editorial in Physics Today a couple years ago about that, and what I said is that hypothesis, the solar variability hypothesis, I called it a non-solution to a non-problem. Okay, and it's a non-solution because in fact we have satellite measurements of the sun's energy output going back 30 years. And it hasn't really changed. It wiggles up and down very slightly, but there's no long-term trend. So there's no reason why, using physics that physicists understand, how that could possibly cause warming. So it's a non-solution, but it's also a non-problem because, as I said, we have an explanation for the warming of the last 50 years. We have a perfectly good explanation that works very well. So if you want to posit another explanation, you not only have to explain why that explanation is right, but you also then have to explain why things that we've understood about greenhouse warming for 200 years are wrong. And that's actually a tougher job. Okay, so more evidence for human causes of climate change. This is just trying to put the 20th century warming into a longer context. And I showed you several times now a surface thermometer record going back to about 1880. It turns out that there's a few thermometer records going back farther than that. There's one in central England that goes back to actually to the early 1700s, and there's a few others that are longer. And if you look at those, you see, pretty much kind of nothing going on until really the 20th century, the middle of the 20th century especially, things rapidly warm up. This, on the bottom panel here, goes back farther. This goes back a little over 1,000 years. And this is sort of a fuzzy line representing actually 10 different estimates of temperature going back 1,000 years. But they all show this, or almost all of them show this, not a hell of a lot going on, and then rapid warming in the last 100 years. So what this is saying is that if you look in the broader context, the warming of the last 100 years seems to be highly unusual. Now, this is actually a key piece of evidence, and I'll try to see if I can explain it, and that is one of the consequences of increasing greenhouse gases is it makes I've showed you it makes the lower atmosphere warmer, but one of the little known facts that actually makes the upper atmosphere cooler, okay? And that's a real key signature of greenhouse warming. And if we look at observations, this is now north, this is actually a slice, think of this as a slice of the atmosphere. So this is North Pole, South Pole, this is the top of the upper atmosphere, this is the lower atmosphere. The blue colors indicate that the upper atmosphere has in fact over the last 50 years gotten cooler. The lower atmosphere has gotten warmer. But this, by the way, this really strong cooling in this far southern, that's the ozone hole, okay? So that's not greenhouse gases. And this is just to show you, if you do model simulations of turning up the solar intensity enough to cause surface warming, you also cause warming in the upper atmosphere. On the other hand, if we simulate in a model warming due to greenhouse gases, it has the basic observed pattern. It has warming in the lower atmosphere, cooling in the upper atmosphere. So that's a real key signature of greenhouse warming. Okay, so because of this evidence and others that I haven't shown you, we have increasing confidence that humans are causing, or the primary cause of recent climate change. And I'm showing you covers of successive IPCC reports and summary statements which indicate over the years and decades increasing confidence that humans are causing climate change. Okay, so what about some societal impacts? Actually just going to mention one because I'm running low on time, but and this is one I'm really interested in, and it's wildfire, okay? And one of the things people don't know, a lot of people don't know about wildfire, you may have some sense that, gee, there's more fire than there used to be, but in fact, area burned by wildfire since 1986 compared to the 25 years before 1986 has increased in the western U.S. by 6 times, okay? A huge increase in wildfire. So what's the cause of that? Well, a lot of that apparently is climate change. And how do we know that? And this is some work from a guy I really like. His name is Jeremy Littell. And he's a real wildfire expert, which I'm not. And what has he done here? First of all, he did a reconstruction of actual fires going back almost 100 years. And that's what the gray curve is, the gray bars, which are a little faint. But what he's showing here is basically the area burned by big fires every year. And this is western U.S., okay? And that's quite interesting, really, because you do see this very rapid increase, which I just mentioned. And if I showed you only the last 50 years, you'd probably think, holy cow, this is really a dramatic increase. But then if you look back farther, you see, wow, the early 20th century was also a period of very high fire activity. In fact, 1919 was the worst fire year ever in the western U.S. So you probably think, well, wait a minute, how can this be climate change if this was just as bad? But in fact, it is climate, and this period, in fact, was warm, although not as warm as the present period, but extremely dry. Okay, so here's what's convincing, and this is what personally convinced me that that wildfire is driven by climate change, and that's this black curve. So what's the black curve? So the black curve is a very simple model that this guy Jeremy concocted, which predicts wildfire activity based only on climate factors. Things like temperature, things like the rainfall the year before, and so on and so on. It's a statistical model. But the point is it only considers climate, and lo and behold, by considering only climate, you can predict both the individual bad fire years and also this long, these variations from decade to decade. So clearly, other factors do affect wildfire activity, although I will say that the much discussed changes in forest management practice, if you talk to the actual wildfire experts, they'll tell you that's actually not a big factor. Climate change and climate variability has been the major factor driving wildfire in the western U.S. Other impacts happening now, which I'm not going to go into, I mentioned increased water scarcity, human health. There's a huge amount of mortality from climate change actually happening right now, and this has been documented by the World Health Organization. Hundreds of thousands of people die, or their deaths are attributed to climate change every single year. Hundreds of thousands of people. It's astonishing. The problem is they're not Americans. Okay, so they don't count. Ecosystem disruption is also a real significant issue, and I'm sure many of you are familiar with the pine bark beetles that have devastated forests in a lot of the not so much in California, but north of here. Okay, so I'm running out of time. let me say something about extreme weather. And I will say this is an area where both societal interest and the science are maturing rapidly. So there's a lot about how climate change affects severe weather. We don't actually understand all that well. What I'm going to do is focus on the things that we do understand well. And one of them is that climate change makes extreme heat more common. That shouldn't surprise you. You've probably experienced it. This is a nice slide done by a colleague, and it shows for each decade, so this is the 50s, 60s, 70s, this is the red bar, this is for the United States, the red bar is the number of high temperature records that were set in that decade, and the blue bar is the number of low temperature records that were set in that decade. And what you expect if the climate isn't changing, as the records get longer, you expect about the same number of high temperature records and low temperature records. And what's happened over the decades is we're getting more and more high temperature records and fewer low temperature records. So it's getting more, we're getting more extremes. This is, I have to, I can't resist showing you a paper by me. And this is, what I tried to do here is document that extreme summer temperatures in the United States are happening more often right now. Okay, it's not a future prediction, it's happening right now. And what I did is I said in every area, well, what this map shows is temperatures that used to happen only 5% of the time, summer temperatures, how often do they happen now, okay? And the answer is in some parts of the West, you can see they're happening 50, 60% of the time, okay? So that means these temperatures that used to be pretty rare, 5% of the time, are now happening 10 times more often, okay? So big increases in what used to be rare summer temperatures. This is now, okay? If you go forward to the middle of the century, those temperatures happen almost all the time, okay? I'll skip over extreme precipitation. Everybody wants to know about hurricanes, right? Is climate change making hurricanes worse? This is an area where we think we understand a couple of things. I'll skip that slide. This is, sorry, this is a lousy slide, but this is from a summary paper that was written a couple of years ago. There's a few statements in here that are noteworthy. One is it's saying it's likely that the global frequency of tropical cyclones, that is hurricanes, will either decrease or remain essentially unchanged, okay? So they're saying if you just look at the total number of hurricanes globally, we don't expect an increase, it may even decrease, okay? So you think, okay, well, that's good. But some increase in the maximum wind speed of tropical cyclones, 2 to 11% is projected, okay? So they get a little stronger. But the really bad news is the frequency of the most intense, rare and high impact storms will more likely than not increase by a substantially larger percentage in some basins, okay? So we do expect fewer hurricanes overall. At this point, this is what we see. Fewer hurricanes overall, but a big increase in the numbers of very severe destructive storms. So that's actually not really great news. Okay, I'm almost done, but okay. Nancy's she's getting the boat hook ready, okay. But I want to mention a couple of things that that the Obama administration has done that I think haven't gotten as much recognition as they should have, and this will lead nicely into Laura's talk. And one actually, which we really shouldn't take credit for, is actually U.S. emissions of carbon dioxide have actually gone down, okay, and that's what this curve is. And a large part of that, it's got to be said, a large part of that is due to the recession. A large part of that is due to the adoption of natural gas for generating electricity, replacing coal, which is in some ways a good thing, in some ways, maybe Laura will discuss, but it's actually, I think, in some ways not a good thing because basically natural gas is so cheap that it is certainly suppressing investment in really clean technology, unfortunately. And I should say this is the so-called Asia-Pacific region, which includes India and China. So their emissions are going up, ours are actually going down. Okay, so one of the great things, we owe a great debt to Mitt Romney, actually, and one of these is the EPA regulation of greenhouse gases. And actually, to be perfectly precise, he didn't start this, but he could have stopped it and didn't. And the history of this is that in 2005, when he was governor of Massachusetts, at that time, this was under Bush, the EPA had adopted the position that they did not have the authority to regulate greenhouse gas emissions. Not that greenhouse gases were harmless, but that it was not within their legal authority to regulate emissions of greenhouse gases. Okay, and they were sued by a number of parties, led by the state of Massachusetts in 2005, which was when Mitt Romney was the governor, and his attorney general started this, but he could have stopped it, he didn't. And these states and other parties sued the EPA and said, you have to regulate greenhouse gases. And this went all the way up to the Supreme Court in 2007. The Supreme Court agreed. In other words, they won the lawsuit. And they told the EPA, you must now make a formal finding to determine whether or not greenhouse gases are indeed harmful. And if you find that they're harmful, you must regulate them. And 2 years later, in 2009, the EPA issued this formal finding called the endangerment finding that said that greenhouse gases do indeed endanger the health and welfare of present and future generations. And they started, and this is now under Obama, they started to actually regulate greenhouse gases. And this is something that the EPA now can do under the Clean Air Act, and it does not require congressional approval. And this, of course, has been challenged in court, but it's been upheld all the way up the line. And so what are they actually doing? Well, so far they've done a couple of things that I think are noteworthy. One is vehicle mileage standards. You all know about that. The other that you may not know about is what's called new source performance standards for electricity generating plants. And what does that mean? What it means is it limits the maximum greenhouse gas emissions from, if you want to build a new plant to generate electricity, it limits the amount of greenhouse gas emissions, and it limits it to what's called, essentially to the amount of emissions that come from a natural gas plant. So the practical impact of that is it means that you cannot build a coal plant anymore in the United States. Now that sounds pretty profound, but the fact is that even before this rule was passed, no one was building or planning to build coal plants because natural gas is so cheap. So in some ways it's profound, in some ways it has absolutely no influence. And this, of course, is only the beginning. Now, the other thing I'll just mention very, very briefly, which I bet you very few of you guys have heard of this, is called the Climate and Clean Air Coalition to limit short-lived climate pollutants. This does not address CO2, so it doesn't go after the big problem, but it goes after other things that cause climate warming that actually contribute to the problem, and also it turns out many of these also cause health problems and so on. So that's significant. The other thing that I would say is significant about this is the process, and the process is, I think, potentially a model for a better CO2 process, and you all know the CO2 process. The CO2 process is you get 193 nations in a room, and you don't agree, and nothing gets done. Okay, and that's been happening for longer than I want to remember. This process was essentially what I would call a coalition of the willing, and that is led by the United States. A number of nations got together who were willing to reduce emissions of these pollutants, and they just said, let's do it. And now they're going around and saying, okay, who else is in? And they've actually recruited quite a number of other nations to participate. So I think it's a great process, and I'm rather proud of it. Okay, so a couple things before I go away. I've mentioned here basic things that we do know. I haven't talked too much about what we don't know, but I don't want to convey the impression that we know absolutely everything. I hope I have conveyed the impression that we do know with a high degree of certainty some very basic and important things about climate change. And as far as that goes, the issue of standards of proof, I think, is very important. And I work a lot with this United Nations body called the IPCC, which summarizes scientific understanding of climate change. And I honestly sometimes get frustrated with them because they will not say anything unless it's been documented, it's down to the last gnat's eyelash. And that's how science works. I mean, science doesn't accept an idea unless they have a very high degree of confidence that it's true. And that's an effective way to do science, okay? But it's not necessarily an effective way to formulate policy, okay? Sometimes in the policy world, you have to do something. If you see a catastrophe coming, you don't have to wait until you're 99% sure that it's going to be here. And we all do this in our personal lives, right? We take measures to mitigate risk in our personal lives, even though, who has fire insurance? This is Steve Schneider's famous. Who has fire insurance on your house? Everybody, right? How confident are you there's going to be a fire? Probably won't be. Very low probability. But the point is, it's more risk than you want to take, okay? So scientists talk a lot about uncertainty, and they're talking about it from the context of doing science. And in science, we require a very high degree of certainty before we move on. In the policy world, that's not necessarily necessary or appropriate. Okay, I think that's everything I wanted to say. Okay, thank you.
Fact or fiction? We have seen a major reduction in our, not major, but a reduction in our greenhouse gases because of the use of natural gas.
Right.
But I've heard and I don't have any idea whether it's true or not, but the fracking process itself is releasing more methane than is reducing the other side. Yeah. So what's the truth?
Okay, I don't know. Well, and it's actually, okay, so the question is about natural gas and extraction of natural gas through hydraulic fracturing, known as fracking. And this is the primary reason why natural gas has all of a sudden become too cheap, which I don't know if it's entirely a good thing, as I said. But the questioner is saying that one of the there's fracking itself has environmental consequences, groundwater contamination. It actually does trigger earthquakes, although apparently not big ones. But and it also, in the process of doing this fracking, methane can be released into the atmosphere, and methane is a very powerful greenhouse gas. And so if a lot of methane is being released by fracking, that undoes a lot of the benefit of substituting natural gas for coal. And it's, let me just say, it's very controversial how much is released that way. And controversial within the scientific community, which is a different world, of course, from the political community, but we really don't know. I will say this, though, and that is that there's no question that in the fracking process that natural gas, that methane can be captured, and in fact it can be captured profitably and sell it. It's natural gas, basically. So it's kind of weird that this is a problem, because in fact if folks were willing to take more time, they could capture the whatever methane is escaping and sell it and actually make money. And it's kind of funny that they don't bother. Yeah.
Hi, thank you for your talk. This question is with regard to the US EPA's regulation of CO2 and the source emissions.
Yeah.
A lot of us have become very concerned about the XL pipeline.
Yeah.
And the cost to the environment of extracting and burning that stuff. I'm wondering if the source regulations include the emissions created by the fuel extraction and its transportation to the plant.
I don't think so. At the moment, they don't.
Is there any wedge that you think might be included to help us to fight that project?
I really don't know, sorry.
Hi. I have a question that actually somebody who is a denial advocate asked me, and I did not have a proper answer, so maybe you can help me should this question come again. Okay. And it was, if this dramatic increase in warming is unprecedented, and I saw many great reasons why now we can say it's probably human-based in your talk today, but the question given to me from this person was, how do we know that any actions we take will have a substantial action or reaction on this process?
Well, it's the rapid warming that we've seen recently it's unprecedented on the scale of the last 1,000 years at least. Okay, it's not necessarily unprecedented in the whole history of the planet. Now, again, that fact should not give you any comfort. The fact that people, one of the things that deniers say always is, "Oh, climate changes all the time. This is natural," and people tend to equate, "Oh, it's natural," with it's okay. But the bottom line is nature really doesn't give a crap if you live or die, and it doesn't give a crap if the human race lives or dies. And species come and go, and nature doesn't care. Okay, so the fact that it's natural and the fact that the climate varies naturally doesn't make me feel any better, because extinction happens, and mass extinctions happen naturally, and I don't want to be part of it. Okay, but the question is, how do we know if we reduce emissions? Well, the fact is, if we reduce emissions, carbon dioxide levels will go down, but it takes actually a long time because we're relying on the ocean and so on to basically suck the carbon dioxide out of the atmosphere. It will happen. I mean, I have no doubt. And it's happened before, okay? And I showed you that history of these large variations in atmospheric CO2. So that happens. It doesn't happen that fast, unfortunately. And so we know from history that it happens. We know from theory it happens. I have no doubt it will happen, but not that fast. Sure.
Okay, I've got another methane question. I wonder if you could speak to the tipping point of methane from permafrost melt. When will we reach that under current trends? How bad will it be?
Yeah.
And also the tipping point in terms of melting of the Greenland and Antarctica land ice causing sea level far beyond what we're now thinking about?
Okay, so that's a great question, and the question has to do with the so-called tipping points, and you mentioned two. These are two that we know about, and one has to do with methane releases, and I'm going to generalize a little bit. You mentioned permafrost, but there's other sources of methane in the high latitude regions. Actually, I think the bigger reservoirs are in the oceans, and these things are known to be they're known to become destabilized when the peat bogs do when the temperature rises. Okay, so the rising temperature tends to cause this methane to be released, and that, of course, as I mentioned, methane's a very powerful greenhouse gas, so that would cause a rapid warming, which would cause more methane to be released and so on. So that's a potential really bad deal. And you're asking, when does that happen? We don't know. And it is a little disconcerting. And, you know, this methane that's been coming up, we've seen now recently, observed methane bubbling up from the surface of the Arctic Ocean. And that seems worrisome to me now. But what we don't know is how long has that been happening? Was that new? Was it there 100 years ago? Don't know. So we don't know. We don't know. And the other tipping point is at some point the melting process of Greenland, which I showed you. I didn't show you Antarctica, but at some point that becomes unstoppable. And when does that happen? I wish I could tell you. So I didn't mention that. Partly lack of time, probably, we really don't know. But these are things, it will become irreversible. At some point, the temperature will go up enough that Greenland is destined to melt, and ain't nothing anybody can do about it. I will say in that regard that the last time the planet was as warm as we think it will be at the end of the century in 2100, sea level was 20 to 30 feet higher than it is now. Okay. Now I'm not saying sea level is going to go up 20 or 30 feet by the end of the century, because it takes a while. Okay. But if we raise the temperature to where we think it's going to be at the end of the century and hold it there, eventually sea level will be 20 or 30 feet higher. So that's a real different kind of planet, right? I mean, you think Hurricane Sandy was bad? That ain't nothing. Okay. Thanks.
And now, it's not.
I'm here to cheer you up a little bit. Talk about some of the things that California is doing to address climate change, specifically in the electricity sector. And you might think, well, there's all sorts of sectors in our economy that are releasing greenhouse gas emissions, so why focus on electricity? And in fact, we have a relatively clean portfolio, which I'll get into. But one thing that I'll talk about is that we love our cars in California. And while 20% of our greenhouse gas emissions today come from electricity, 40% come from our transportation sector. And from the analysis that's been done so far, really the only way we're going to reduce the emissions in our transportation sector is by electrifying most of the transportation fleet. So clean electricity is going to play an increasingly important role in our climate solutions, both for keeping the lights on, but also for helping us get around much cleaner. So, okay. So just a little bit about me. I grew up in St. Louis, Missouri, which is actually headquarters for two of the largest coal companies in the country, Peabody Coal and Arch Coal. So I've been aware of the implications of burning dirty energy and climate change for a while, but I actually came to California to work on river issues, to run a small nonprofit that worked on FERC hydropower relicensing and reoperating rivers and hydropower. So anyway, I learned a lot about climate change and the impacts of what it was going to do to our river systems and our water supply, and so I became much more interested in renewable energy. So it keeps going to this slide, so I'm just going to start there. Before I get into some of the solutions, I just wanted to make sure that everybody had a good snapshot of where we get our electricity today. So this slide shows the makeup of our electricity from 2002 to 2011. And as you can see, going up from the bottom, We get about 2% of our electricity from in-state coal generation, another 6% from that red imported coal, and another 34% from natural gas. So even though that California has one of the cleanest electricity portfolios in the country, we still rely on fossil fuels for about 40% of our electricity today. Then, as you can see, nuclear and large hydro, it's roughly equal depending on the water year for the large hydro. And in 2011, we received about 15% of our electricity from renewable resources, which is really exciting, one of the largest in the country. It's also interesting and I think important to note that California is one of the largest importers of electricity, which is the purple bar. We get power from the Pacific Northwest, and we also get power from the Southwest. And that's a mixture of coal and natural gas, plus a little bit of nuclear and large hydropower. Okay, let's try this again. Okay. So one of the largest driving factors towards the transition to cleaner electricity supplies in California, and a focus of my work since I've been at UCS since 2008, has been the renewables portfolio standard, which is basically the requirement that utilities must deliver a certain percentage of their sales from renewable resources by a certain year. So the first policy that we passed was in 2002, and that required the 3 privately owned utilities in the state, Pacific Gas and Electric, San Diego, Southern California Edison, and San Diego Gas and Electric, to deliver 20% of their electricity supplies by the year from renewables by the year 2017. Schwarzenegger came in and accelerated that to 2010. We started working on raising that renewable portfolio standard requirement, the RPS, to 33% by 2020, and making sure that this next time around, it wasn't just the 3 investor-owned utilities that were required to invest in renewables, but actually all the utilities in the state, the publicly owned utilities as well. There's over 40 publicly owned utilities in California, and up until this last RPS, which was enacted in 2011, it was only a voluntary requirement. It was only a voluntary policy. They weren't required to invest in renewables. So I'm happy to say that after 3 years, 1 governor veto, 1 year in 2010, standing in the halls of Sacramento and watching the clock strike midnight in the Senate, running out of time to vote on the bill, and then a special session in 2011, we actually did pass the 33% RPS. It is the most aggressive renewable portfolio standard in the country. Since California is the 9th largest economy, it's actually one of the largest renewable markets in the world. So it's really driving investment not only in California, but other Western states. And so what is our renewable portfolio? So this is a deeper dive into where we get our renewables. And most people, when they think of renewables, they think of solar and they think of wind. So it's surprising to some people when they look at our portfolio and they realize that actually over half of the renewables that we get today in California come from biomass, geothermal, and small hydropower resources. And most of those facilities were actually in existence and generating electricity before we even passed the first RPS. So it's really been in the last 5 or 6 years that these projects have started to come online as a result of passing the first RPS, that we're starting to see new generation, which is really exciting because then we're actually growing the renewable resources on the grid. So as you can see, solar is still a pretty small portion of the renewable picture right now. I can go into that a little bit more because this is just representing the solar that's sold directly to the grid. This doesn't represent the solar that we put on our rooftops and we use to generate our own electricity. That's a different set of policies. And as you can see, wind has really exploded over the last couple years. In 2011, it was the largest year-to-year increase in renewables for the state, and that was mostly due to wind. But as you can see in the future, what we expect to come online as a result of the RPS is much different than how it looked in the past. So the green bars are showing you what's generating now, what's already been built, and the blue bars show you what has been approved and what is expected to be built through 2020. So as you can see, we're expecting a lot more solar PV, a lot more solar thermal, which is concentrated solar thermal, which is not using photovoltaics, but instead basically training the heat of the sun on a liquid and generating steam and then using it to generate electricity in a conventional turbine, and some more wind. And so I wanted to talk about what other policy initiatives the state has been working on to address climate change and clean up the energy sector, in addition to the renewables portfolio standard. So who's heard of AB 32? Okay, well, I'm going to talk about it anyway. So AB 32, the reason why I want to talk about it is because most people, when they think about AB 32, Assembly Bill 32, which was enacted in 2006, they usually think of cap and trade, when actually it's much more than cap and trade. It's a suite of policies that's intended to reduce our greenhouse gas emissions in the state to 1990 levels by the year 2020. And so what this chart is showing you is that cap and trade, which is the top 20%, cap and trade's only going to get us 20% of the way there. There's a whole suite of other policies related to renewable energy, and so the renewable energy is the renewables portfolio standard, as well as some of our policies that encourage more rooftop installations. But then we also have tailpipe emission standards. We have potent greenhouse gas emission regulations. We have a very aggressive energy efficiency goal. And we have other clean fuel standards. And I'm happy to go into more of those policies if you guys have questions about those later on. So another major policy that we've enacted and that we enacted in 2006 was called the California Solar Initiative. And so this is specifically focused on promoting the installation of photovoltaic solar cells on rooftops, our homes, our businesses, our commercial buildings. And the California Solar Initiative established a goal to install 3 gigawatts, 3,000 megawatts of solar in the state by the year 2016, and we're already a third of the way there, so it's actually been a very successful program. And I'm just curious, how many people have solar on their roofs today? Okay, so quite a number of you. So in addition to the CSI, which provides rebates, and that rebate, the level of that rebate goes down as we install more and more solar in the state, is a policy called net metering, and that's been a real driver for solar installation. So basically the concept of net metering is that if you install solar on your roof and you're generating your own electricity, you get a bill, you get a credit on your bill for the electricity that you would have otherwise purchased from the utility. So that's a really important economic incentive for people to install solar. And here's just a snapshot of how the PV market has grown in California cumulatively since 2006. So California has the largest photovoltaic market in the country. And as you can see, in 2011, we surpassed the 1 gigawatt mark, which means that we're generating enough electricity to power about 100,000 homes in the state just by solar PV. So it's pretty exciting. Another policy that people may not be as aware of, but has been a huge driver in the state turning its back on coal-fired generation, is called the Emissions Performance Standard. This is another policy that was enacted in 2006. 2006 was a pretty exciting year for the environmental community. Basically, what this law does is it prohibits a utility from signing up a new coal contract or renewing a coal contract that they already have. So this is actually going to be a big deal. We expect that 60% of the coal generation that we rely upon is going to be phased out through the Emissions Performance Standard by the year 2020. It's especially important for Southern California. So Los Angeles Department of Water and Power, who's the third largest utility in the state and the largest publicly owned utility in the country, has a very coal-heavy portfolio. They own a coal plant in Utah, the Intermountain Power Plant, and they have a large holding in another plant in Arizona. And the Emissions Performance Standard is forcing them to divest their interest. Their interest in the Navajo plant in Arizona will need to be gone by 2017, hopefully, if this law stays strong. And they need to walk away from the Intermountain Power Plant by 2027. And then another thing that I wanted to talk about that I think makes California unique and something that UCS has been working on is making sure that California continues to invest in research and development. So when you compare, and I wish I had a slide on this, but if you looked at the amount of research and development that's gone into fossil fuel extraction, deep water oil drilling, natural gas fracking, compared to the research and development that's gone into making more efficient, cheaper, more reliable renewable energy facilities it's a fraction of the amount. And fortunately, California has been a leader in directing state money towards clean energy RD&D. So we've had a program for the past 10 years called the Public Interest Energy Research Program that's been administered by the California Energy Commission. And the program has been paid for by us as ratepayers. We pay a very small surcharge on our electricity bill that goes into a fund that's been used to fund a lot of really important climate change research for the state, and also some investments in clean energy. So that program actually expired in 2012. And there was a bill in the legislature to reauthorize it last year. And unfortunately, it didn't make it through the assembly. There's a lot of reasons why I don't think the Energy Commission presented a strong enough case about the value that their research has provided to the state and to electricity ratepayers. But nonetheless, Jerry Brown required the California Public Utilities Commission to go ahead with the program anyway, since they do, as an agency, have authority to make decisions over how ratepayers spend their money. So the program is moving forward. It's been renamed. Now it's called EPIC, which is sort of appropriate because there's been an epic change in its focus, but it continues. It's going to be it's going to disperse about $170 million per year for clean energy. There's still going to be a focus on understanding the impacts of climate change to the electricity grid. So there's actually a lot of reasons why we should be worried about reliability when it comes to climate change. Forest fires, for instance, are dramatically, if they don't take down a power line, extreme heat events can reduce the efficiency of transmitting electricity over long distances. So there's a lot of reasons why we need to better understand the resiliency of our electricity grid in the face of climate change. And then finally, just because I get this question a lot, I focus on the supply side of the clean energy transition, the renewable energy, but of course, the cheapest and cleanest way to get more clean energy is just not to use energy. So I always want to make a point to talk about energy efficiency. We do have a very aggressive program in the state. Our building codes, our appliance standards, and the utility programs that they're required to do every 2 years are some of the most aggressive in the country, and to date have saved enough electricity that's equivalent to about 30 power plants in the state. So it's really been huge. And I'm sure most of you know that the voters this November passed Prop 39, which is going to close a corporate tax loophole in the state and take that money and use it to fund energy efficiency improvements and retrofits, mostly in schools. That's still up for the legislature to decide, but it's intended for schools. So, excuse me, I've been sick. I'm losing my voice. I also thought it'd be interesting just to talk about some of the unexpected events that have changed our clean energy landscape over the past couple of years, things that policymakers can't control. So one of the biggest ones has been the fact that our second largest power plant in the state and our largest nuclear facility, San Onofre, which is down in Orange County and surrounded by about 8 million people, has been unexpectedly offline for almost a year. It went down, it was taken offline January 31st, 2012. So we've been grappling without it for about a year. And it's been giving us, it's given us a really important opportunity to understand whether we could live without that plant. And if we want to think about living without that plant, how would we replace that electricity? And if we decide we want to replace that electricity, is there a way to replace some of that electricity, not with building new natural gas plants, because we don't want to do that for greenhouse gas reasons, obviously, but also it's going to be very, very difficult just to build and get the air quality permits to build new natural gas in Southern California. Can we do this with renewables? Can we do this with energy efficiency? Can we do this with demand response? So this is an ongoing proceeding at the California Public Utilities Commission that we've been involved in, really pushing the state to take seriously some of these alternatives to building natural gas as a way to backfill San Onofre, because we're not sure it's going to come back online. Another big thing that's been changing the landscape is the fact that the State Water Resources Control Board in 2010 enacted a regulation that's going to require 19 coastal gas plants to either shut down completely or retrofit themselves. So these are called once through cooled plants because they suck in seawater to cool their operations and then spit it back out into the ocean, and it's having detrimental effects on sea life and water quality. This is a big deal from an energy perspective because these 19 plants represent about 25% of our generation capacity. So it's causing the grid operators some heartache because right now the easiest off-the-shelf way to manage the electricity system, and remember, we're flipping on our lights all the time. It's unpredictable. We have to plan for major power lines going down. We have to plan for major power plants going offline. We need to have reserves. And today, the off-the-shelf reserves that we have are gas plants, and the ones on the coast are the most flexible plants, and so those are the ones that the grid operator relies upon. So this is a major challenge that we're facing as a state. How are we going to replace this flexible generation, and is there a way that we can do it cleaner? And then finally, and this is a success story, we've seen the price of photovoltaic modules decrease dramatically over the past 4 years. The price for just modules has gone down by about 75%. So that's obviously had huge impacts on the economics of solar, and that's it's done a lot of really good things. It's allowed solar companies to be much more creative with their financing and lower the upfront costs for people that are interested in having solar on their roofs. And it's basically democratized the solar market. We are seeing much more installations of solar PV in the state be installed in places like the Central Valley, where it actually makes a lot of sense because we get a lot more sun there. There's no fog. So I also wanted to talk a little bit about some of the challenges we're facing in California, since we are kind of on the forefront of putting more and more renewable energy on the grid. It's not without its challenges. And I think that it's important for us to be thoughtful and get this stuff right, because the rest of the country is watching us, and basically we're the proving ground to show that we can, go beyond 33%, that we can rely on more and more sources of renewable electricity and maintain reliability on the grid. So this is a picture of photovoltaic cells. I'm not just picking on PV here. This is a challenge with lots of different types of renewable energy resources. But like I said before, the easiest way to control the supply side of the grid is just to flip a switch, flip a power plant switch. You can't necessarily do that with renewable energy because we're somewhat dependent on it generating when it shows up. So solar right now, because we haven't come up with cost-effective ways to store it, we can only have that electricity when the sun is shining. When the sun sets, it drops off steeply. We can only have electricity from wind when the wind is blowing. In California, wind tends to blow in the middle of the night when we don't necessarily need that electricity as much. So it is presenting some challenges to the grid operators to figure out how to backfill those peaks and valleys that are created by intermittent generation. And so there's several different strategies that we can take, tools that we have in our toolbox today to manage some of that intermittency, but it's not easy, and California is facing these issues before anybody else in the rest of the country. So, not to go into a lot of detail about this, but there's a couple things that the grid operator can do and is doing to make their job easier. The first one is better forecasting tools. So the more we are able to accurately predict when renewable energy will show up and when it won't show up, the better we're able to plan for it, which means that we don't have to build in as many insurance policies. And insurance policies in the electricity world are extra natural gas plants. So the more effective we are at forecasting, the better we will be at planning, the more efficient we will be at running the grid. Another thing that we can do is we can find cost-effective ways to store this electricity. We do have ways to store it. Right now, a lot of them are pretty expensive. So how do you drive down the cost of storage? Well, you invest in it. Well, how do you invest in it? How do you get the industry to actually finance new storage projects? One of the problems in California is that for the market for electricity that provides backup power generation, we only allow backup power plant providers to get a contract for a year. And that's not enough time to finance a new facility, especially if it's something a little bit considered risky in the financial community. So one of the things that we're doing is we're working with the state to provide longer term markets that provide a long-term revenue stream for a potential developer, then they can go out and get the financing for a specific type of storage. Another big challenge is, like I said, we're going to really need to electrify a significant part of our vehicle fleet. And so how do we do that? How do we prepare our grid to handle all this additional electricity? And how do we send the right financial signal to the owners of the electric vehicles to make sure that they're charging at a time when it's not actually adding more stress to the grid? So the best time to charge is in the middle of the night, because at that point we have a low electricity demand and we have a lot of power plants that are able to provide electricity. If everybody plugs in their car in the middle of the day on a hot day when everyone's cranking their AC, it's going to be a lot harder to supply all that electricity. So we need to make sure we get the charging patterns right. And this is just a graph that shows a little bit more about why we're going to have to electrify our vehicle fleet. So one of the things that UCS has been looking at is, what do we do after 2020? 2020 is actually just around the corner. When we talk about making transitions in the electricity sector, it's going to take long-term investments, both in new power plants, retrofitting homes and businesses for energy efficiency, potentially new transmission lines to access renewable energy resources. All this is long-term investment. So 2020 is just around the corner. What's going to happen after 2020? There's been two really interesting reports written in the last couple years that have taken a pretty high-level stab at what the grid and what the state would look like in the year 2050 if we were to reach our longer-term greenhouse gas emission reduction goals. So remember, AB 32 said the state must reduce its emissions down to 1990 levels by 2020. There's a longer-term executive order that isn't law, but it's still a goal that we're holding the state to, which says that we need to reduce our emissions 80% below 1990 levels by the year 2050. And so both of these reports looked at, well, if we were actually going to take that goal seriously, what would the state look like? And so as you can see, for all the sectors listed here, residential, commercial, industrial, and petroleum and agriculture, we're going to need to dramatically reduce our electricity consumption. So we're going to have to get a lot more serious about energy efficiency. But the red line shows what our electricity use is projected if we did nothing. And actually, if we're going to reduce our greenhouse gas emissions, we're actually going to be using more electricity than we would otherwise, because so much of it is going to be dedicated towards the transportation fleet. And of course, if we supply that electricity by building new natural gas plants, which emit greenhouse gases, albeit less than coal plants, we're not going to meet our goals. So the great majority of that electricity needs to come from clean resources. And yeah, so this is one of the things that UCS is looking at. We are working in several different venues to really push the state to start talking about what happens after 2020. The RPS, for one, we have a requirement to reach 33%, but then after 33%, the utilities can just basically hit cruise control, and that's what they're planning for now. And we know that it takes years to get policies like the RPS hammered out and actually through both houses of the legislature and signed by the governor. We can't wait until that policy is official to start making the investments that we'll need to take us beyond 2020. So those are some of the things that we're thinking about. And I'll just end on a positive note. So you probably can't see all this, but this just gives you a perspective of how large California's market is for renewable electricity and how much of a leader we are for the country. So the y-axis shows all the states in the country that have renewable energy laws. There's 29 states and the District of Columbia that have renewable energy laws on the books. And California is the second from the bottom. We are by far and away the largest state in the country that with our renewable energy standards. So we need to continue to lead, and hopefully UCS will be around to make sure we do that. And that's it.
You said that by 2020 we're supposed to be 80% of our 1990 levels.
By 2050.
No, that 20% less. What was it?
AB 32 requires reach our 1990 levels by the year 2020, and then there's an executive order that sets this goal for us to reduce our emissions 80% below 1990 levels by 2050.
Okay, and the one we have to hit by 2020 is
1990 levels.
We have to hit those levels.
Yeah.
And we passed that law about 7 years ago?
We passed it in 2006.
Yeah, so we're about halfway through that process.
Yeah.
I was wondering how we're doing.
It's a good question. We need to get going. I don't have those numbers actually. So we've established our greenhouse gas emission inventory when the Air Resources Board put forth a scoping plan on how AB 32 is going to be implemented. I actually don't know. I'm sure somebody in my office does. I know that it's not going to be a linear trend, obviously, because things like the RPS were passed years ago, but we're really only starting to see the benefits of it now as years later steel gets in the ground and projects get built. So we're hoping that these policies that we're working on now are going to, we're going to get benefits from them later on. But I think it's safe to say that we're not in the clear just yet.
Okay. Are there any, is there any planning being done to use people's individual electric vehicles as storage for renewable energy?
Yeah, it's an interesting question. So the concept is right now we're struggling to find cost-effective ways to store renewable electricity, especially when it shows up and we don't need it. So when the wind's blowing in the middle of the night, sometimes now we just have to dump that electricity, or we actually have to pay another state to take it. And the thought is, if we have all these electric vehicles plugged into the grid at night, could the grid operator basically take that electricity and shift it all into your batteries and charge up your battery? And then if there are times when we need electricity, could the grid operator similarly take electricity from your battery and use it, and use your cars like a storage facility? So it is something that's being studied. I think it's still pretty far out there in the future for a couple reasons. First of all, the battery technology today gets pretty worn down when you charge and recharge so quickly like that. So it does create some wear and tear. Also, I don't think that people love the idea of the grid operator taking electricity from you when you don't. So it's an evolving concept, but it is something that's being looked at, and that's actually one of the focuses of research in the Clean Energy R&D program that I was talking about.
I'm not saying this because Damon's sitting right behind me, but people in this room may not realize you have a unique opportunity. One of the sources of new renewable energy in the state are the projects that are being driven by the CCAs. Marin Clean Energy, to be followed shortly by Sonoma County and the city of San Francisco. And if you haven't signed up for Deep Green already, shame on you. But signing up for Deep Green and paying, $5 a month more on your electric bill will put money into new generation, both industrial scale projects out in the valley and these little 1 megawatt projects like the one at the San Rafael Airport, which are a unique creation of the CCAs, really. The big utilities aren't even paying attention to them. And with luck, we'll have several dozen of those in Marin in the next 10 years.
Yeah, thank you, Laura. And I understand that you're dealing primarily with the supply side of the renewable situation, but there's that intermediary that is not being discussed. That's not necessarily conservation, but it deals with the smart grid and having an interactive grid, and the issue of smart meters and how they fit in within that concept. And I think within the county of Marin, there's quite a bit of controversy about smart meters. And yet I think people need to understand the role of smart meters within the context of that smart grid, and what are the real potentials, and why do the people who promote smart grids know how important smart meters are.
So one of the areas that California is actually lagging behind other parts of the country is this concept called demand response, which is not energy efficiency, which is just completely reducing your electricity usage, but shifting your usage towards times when the grid is less stressed, which means we need to have less power plants online to ensure that there will be something when you want to turn your lights on or run your dishwasher or do your laundry. So I didn't get into the topic of demand response, but it is something that the state is starting to take more seriously. We've been doing demand response program for the commercial and industrial sectors for a while. I don't think we've been doing it very well, but the state is starting to think about what's the role of the residential electricity user with demand response, and can we be more informed customers of electricity and consume more of our electricity when the price is lower and when we're not firing up that last dirty peaker on the grid, both in terms of air quality as well as in terms of building new generation. So smart meters are one of the first steps that we would need to be able to be those more informed electricity customers, because what smart meters do is they tell us our minute by minute electricity usage and what the wholesale price of that electricity is. So there is a lot of controversy around smart meters. We don't really have a position on the health impacts of smart meters. I think that I'm not sure I want to go there because I don't know how people feel about this, but we as an organization, although we haven't done any independent research on this, we do think smart meters are an important step in everyday people taking more responsibility for their electricity usage.
A question for Phil. Are there more scientists currently working on climate change than there were 5 or 10 years ago? And do we need even more doing that?
No one's ever asked me that. I think the answer is probably not. And I'm basing that answer on what I know about the federal budget, which is something I spent a lot of last year thinking about, the federal budget for global change research. And that actually hasn't changed, surprisingly, hasn't changed all that much, actually, going back 20 years. And it actually sounds like a lot of money, maybe. The federal budget for global change research varies it's around $2 billion a year. It's actually crept up a little bit under Obama. But it's surprising how, Clinton, Bush, Obama, it goes up plus or minus 10%, but not much more than that. And so for there to be a lot more people working on climate change, there would have to be more money to pay them. And so I'm pretty sure that there aren't. But since you raised it, actually I raised the topic of the federal budget, it's interesting to see. I mean, some people think, oh my God, that's so much money, $2 billion a year. Haven't you guys figured this all out yet? $2 billion a year in the land of the federal government is actually not all that much money. And to put it in contrast, well, first of all, half of that $2 billion pays for NASA satellites. Now, NASA satellites are an important resource for climate change, but they serve many other purposes as well. And so it's really not, well, so it's really sort of $1 billion plus satellites is the way I think of it. And again, $1 billion is a lot of money, but, think of all the things. I mean, it's not even one bomber, and the last time I looked, well, the federal government, for example, spends 5 years ago they spent $23 billion on farm subsidies. That's actually been substantially reduced to the credit of Congress, but it's still 10 times more than they spend on global change research. So it's not really, the research side of global change has not been a really high priority. I think there's a lot. As a scientist, I can say there's certainly a lot more that we should understand. And the topic I'm really interested in right now is what we call adaptation, and that means practical coping measures to cope with, to prepare for climate change, impacts like wildfire and sea level rise and all of these things and extreme weather. And is that really, I wouldn't exactly call that necessarily research, but it's certainly an important activity, and that's, I think, something we really need to put a lot more thought and effort into, is understanding how do we prepare for climate change, because it's, as I showed, it's not that it's coming, it's here, and the impacts are here, and in the long run, it'll save us a lot of money if we prepare intelligently.
Laura, you spoke about energy efficiency, and I know that you're a demand side person, a supply side person. But for many people, energy efficiency is kind of like CO2. You can't see it. It's a mystery. It's abstract. And I know that the state has set aside funds and is developing initiatives to create more energy efficiency programs. We all have some experience with government programs kind of being a lot of money spent for not a lot of result. I wonder if you could kind of give us a high-level understanding of what's the plan, how's it being implemented, and what can we expect what is expected to result in terms of savings of the negawatt?
Okay, I can do my best. So going back to the slide about AB 32, energy efficiency, relying on more aggressive measures of energy efficiency is actually one of the key building blocks to how we're going to get from point A to point B in terms of our greenhouse gas emission reductions. And the two studies that I mentioned that looked at what we need to do out through 2050 also assume that we're going to achieve about an additional 1% energy efficiency savings per year, which is not impossible, but it's pretty aggressive. And one of the studies, and I haven't looked into the details of this, so I'm just going to say what it says that we have to basically retrofit about 80% of our existing buildings, and it may be cheaper to just rebuild them. And obviously that's not going to happen because, California also cares about things like its historical heritage. So it's a complicated issue, but what I know is that the utilities are required by the PUC to put forth energy efficiency investment programs every 2 years, and under that they are required by law to achieve all cost-effective energy efficiency measures, and they actually get paid for it. So years ago, they used to make their money by investing in facilities and selling electricity. Now they also get paid for saving electricity. So that's a huge benefit. That's a huge policy improvement. But the word cost effective gets redefined every 2 years, and people argue about it. They argue about whether those efficiency gains would have happened anyway. And so it's slower than we would like. I know that there's also some question about whether the utilities are the best managers of the energy efficiency programs themselves. I'm trying to be diplomatic here. Right now they are in charge of their energy efficiency programs, but there's been a push to get the PUC to start looking at should third parties actually take this over for the utilities, and would they be better marketers? Utilities don't do the greatest job talking to their customers. As we can see with the smart meters, they did a horrible job helping us understand what they're there for. So there's a lot of room for improvement with that.
I have a question about the future of the supply side. Right now, we've got a lot of big infrastructure supply. Where do you see the mix of distributed generation versus infrastructure generation, say, in 2050?
I think that there's no question that we're going to really have to, for many reasons, start investing more in distributed generation. We are planning to build several very large solar projects on public land, sometimes very biologically diverse public land, and it's very expensive to mitigate some of those environmental impacts, and also very controversial, and sometimes it takes years to really understand the impacts. So there's a lot of biological and ecological reasons why it makes sense to build as much renewable energy as we can in areas that have already been developed. And for the most part, that's going to be rooftops, parking lots, retired farmlands that are too saline or, are not productive anymore. So I do think it's going to be leaning more towards that way. And as you look at the different types of policies that the state has focused on in the years since we started first talking about an RPS, we have focused more on developing policies that try to incentivize distributed generation. So we've expanded a feed-in tariff program in the last couple years that is hopefully going to make it easier for smaller scale solar providers to build projects quicker. We have several different programs to create more distributed generation. So I think we're going to have to go in that direction.
I don't think I'm going to worry about this being on our video, so I'm going to get away from the podium. And thank Phil and Laura so much for the insights that you've given us here tonight, and thank everybody for your questions. Oops. I would like to just take a quick minute to tell you about our next session on February 9th. Again, it's Climate Change Marin's Response. Some of this has been alluded to tonight, and if you come back on February 9th, you'll get more information, particularly in regards to, for example, energy efficiency. We will have an energy efficiency expert to talk to everybody about what you can do in your homes to make them more energy efficient. And as we've heard tonight, this is going to be really a key part of meeting our goals. Hello? Okay. So Marin Clean Energy, representative from Marin Clean Energy to talk more about the services that they're providing and the need to get on that right away. The smart growth is another important component. So we'll have someone to speak to that, as well as I mentioned earlier, wildfires are an issue nationwide and certainly here in Marin County, as well as sea level rise. There are things that we can all do as individuals without worrying about, okay, we got to wait for these policies to get passed. There's a big political process and it gets very frustrating. Well, you don't have to wait for that to make a difference. And that's also what we want to talk to you about more next week. In that, and if you're interested, you can either sign up in the lobby when you leave or go online to our website and you can sign up there to come again next time. I just want to mention Marin County's goals are to reduce greenhouse gas emissions 15% below 1990 levels by 2020. So when Laura talks about AB 32 and our statewide goals, Marin County has a responsibility to do their part. And therefore, each of us in this room has a responsibility to do our part. On that note, I'm going to hand the mic over to Frances Aubrey. She is with 350.org Bay Area, recently founded chapter right here in the Bay Area. 350 is an amazing organization, started nationwide, worldwide actually, by Bill McKibben. Speaking of, I'm just going to give a little plug. Bill McKibben wrote an amazing article in Rolling Stone in July 2012. I really urge everybody to read this article. It puts a different face and light on what this whole situation is about. And I'll leave it at that, and I'm going to turn this over to Frances.
Wow, this is such a fabulous series. I'm so glad I came. Thank you for letting me come. You've probably, since most of you seem to understand a lot about the environmental movement, you've heard of 350.org, I would guess. But what you may not have known is that a new chapter of 350 started in the Bay Area last month, in December. And so we started just before Bill McKibben came to speak several times here. And we got our website up, we got our t-shirts printed, we got our business cards printed all that week before we got here. So we were just wildly busy. And now we have completely launched. We had 80 people at that first meeting in December. And we now have 5 campaigns that we're running, one of which is the tar sands campaign. And I'll mention the others, but I just want to stress the tar sands campaign because there's a huge rally coming up, and you've probably heard of it, in D.C., February 17th, President's Day weekend. They've got, I think, 20,000 people signed up already, which will make it the largest rally around climate in the history of the country. The second largest rally is going to be here in San Francisco. And we are just so psyched about it. I've been working 60-hour weeks on it, and I'm just a volunteer. So, I mean, we're just really excited. We've got NRDC as a co-sponsor here for our rally, Sierra Club, the 2 Loma Prieta and Bay Area, and Credo, Center for Biological Diversity, and a number of other organizations who are going right in with us and sending notices out to their members. So we hope to have a lot of people, several thousand people here for this rally. And our email or our website is 350bayarea.org, and I've got business cards you can take home if you like. But please check it out and sign up to come. And I want to answer one of the, somebody mentioned that what if the climate deniers are wrong or right? Okay, so this is our T-shirt, and this is the back of the T-shirt, and this is a cartoon by Joel Pett, and it's a big lecture hall, and the lecturer is up there pointing to things like cleaner air, better water, so forth and so on. And one of the attendees at the lecture is turning to the other one and saying, "What if it's all a hoax and we fix the world for nothing?" So we love that, and we got Joel Pett's permission to put it on our T-shirts. And then on the front is a whole bunch of slogans, climate slogans like "What's cooking Gaia?" and "Real conservatives conserve the earth," and things like that. So come up and ask me questions. I don't want to take any longer. You've been here a while. Thank you so much, and please come to the rally. Take care.
Kiki, did you have something you wanted to say?
Thank you. Thank you, Francis. The Sustainables are also promoting the rally on the 17th, and it's very critical that we make ourselves heard here and in Washington. We must not allow the XL pipeline to be completed. If that material comes out of the ground and is refined and is burned, as Bill McKibben said in his amazing article, "The Terrifying New Math," it's game over for the climate. So I can now also quote Dr. James Hansen. So the Sustainables are meeting at the Ferry Plaza, at the Ferry Building at 11 o'clock. 11:40 boat on Sunday, the 17th of February, and we will be ferrying over and meeting up with the rest of the gang, the second largest climate rally in the United States. We want it to be a climate rally about stopping the XL pipeline. And the other very, very important thing is that on the Sustainable San Rafael website, we have posted talking points and sample letters that are very, very easy to download and access to be able to dash off a quick note to our representatives and our policymakers in Washington to get them to make the change that we want them to make. This is our country, it's our air, it's our resources, and it's our kids' future. So thank you.
SustainableSanRafael.org. Really read that article, I can't tell you enough. Francis, didn't you say last week that a handwritten letter is counted as 100 letters as opposed to an email? So handwritten letters make a huge impact, and the fact that they've got sample letters on the website of Sustainables is so helpful, because sometimes we get a little stuck and we say, I'd love to write a letter, but I'm really not sure what I should say, and I don't want to sound stupid or whatever. The letters are there. So you can take the text, handwrite it, do a little editing, personalize it if that makes sense for you, and mail those in. I presume, Kiki, all the information where to mail them and stuff is all there too. That's great. Okay, thank you all so much. I want to read something to you. This is my parting words to you. I've been studying climate change for about 3 years now, and my heart is breaking. And I want to read this to you because I think it's really important. This is an excerpt from a poem by Drew Dellinger. It's 3:23 in the morning and I'm awake because my great-great-grandchildren won't let me sleep. My great-great-grandchildren ask me in dreams, what did you do while the planet was plundered? What did you do when the earth was unraveling? Surely you did something when the seasons started failing, as the mammals, reptiles, birds were all dying? Did you fill the streets with protest when democracy was stolen? What did you do once you knew? Thank you, everybody.